Good morning, children. We are going to continue with chapter 6 of NCERT, that is life processes. In our previous presentation, we have started nutrition in human, in which we have discussed how food is mechanically digested in mouth and moves to esophagus. Now we will continue with the stomach part of alimentary canal. Topics which are being covered in this tutorial are stomach, in which we have to discuss about cell composition and secretion. Then we will discuss peptic ulcer, small intestine, large intestine, and finally we will discuss accessory glands being associated with alimentary canal. Stomach. In stomach, gastric secretion used to be secreted by stomach lining. Stomach lining comprises of three kinds of cells. These are mucous cells, parietal cells, and chief cells. Mucous cells, as the word suggests, going to secrete mucus. Mucus used to protect the stomach lining from abrasion by the food. Parietal cells are the very important cells going to secrete HCl. HCl is hydrochloric acid and it is very acidic in nature. The pH value ranges from 2 to 3. HCl plays two important functions in stomach. It provides acidic medium for the activation of enzymes and it also used to kill bacteria or microbes which are coming along with the food. Now we will discuss about chief cells. Chief cells going to secrete two important enzymes, that is pepsin and renin. These enzymes are meant to digest proteins. Whatever gram, moong, chana you used to eat, these are having protein content. And protein content are going to be digested in the stomach with the help of two enzymes. These are pepsin and renin. So sometimes pepsin and renin also referred as protein digesting enzyme. So gastric secretion comprises of mucus, HCl and protein digesting enzymes. These are pepsin and renin. Now comes to the peptic ulcer. This is very important topic being associated with the stomach. What are peptic ulcers? These are depressed lesions or deep lesions on the stomach membrane. Which membrane is going to be affected by peptic ulcer? This is mucosal membrane. Okay. Why these used to develop and causes a damage to the mucosal membrane? Because of excess secretion of gastric juices. As we know from previous discussion, gastric juices also comprises of HCl and it is very acidic in nature. When excess amount of HCl going to be secreted into the stomach, what's going to happen next? That is development of depressed lesions or deep lesions on the mucosal membrane. What are the causes of the development of these type of ulcers in the stomach? First of all, we have to understand that bad lifestyle, that is excess consumption of tea, coffee, or any alcoholic drink used to cause these deep lesions or depressed lesions on the wall of the stomach. And one important factor which also play a vital role in development of these lesions is bacteria. And which bacteria? That is Helicobacter pylori. This bacteria is also responsible for development of the peptic ulcer. If the person is following a very good lifestyle but is being impacted by Helicobacter pylori, then the person is also going to develop peptic ulcer. Okay, so there are two important reasons for the development of peptic ulcer. One is a bad lifestyle, that is excess consumption of tea, coffee, or alcoholic drink. And one important bacteria, that is Helicobacter pylori, is also responsible for the development of these depressed lesions or deep lesions. And what's going to happen because of these ulcers? That is damage to the mucosal membrane. This secretion, that is excess of gastric secretion, going to erode the mucosal lining. Okay. Now we have to see the animation part. First of all, that is, you can see the deep or depressed lesion on the wall of the stomach, and which membrane is going to be affected by peptic ulcer, that is mucosal membrane. And why this is going to be affected? Because of excess secretion of gastric juices, and in these juices we know very important component, that is HCl. HCl is highly acidic in nature and used to damage the membrane of the stomach. As you know, the mucosal membrane is responsible for the protection of the stomach lining, and if this lining is going to be damaged, this is going to be very serious case, and deep or depressed lesions are going to be formed out, and these deep or depressed lesions are referred as peptic ulcers. Some of the persons used to say like that, I am suffering from acidity. That acidity is actually means that excess secretion of gastric juices, and these gastric juices ultimately led to the formation of deep or depressed lesions, and these lesions are the peptic ulcer. I hope you have understood this point. Now comes to the small intestine. Small intestine is a tube-like structure, and it is the longest part of the alimentary canal. In human, it is approximately 7 meter long, and it is highly coiled, folded into the abdomen section of the body. You can see over here a blue color tube-like structure is coming from the stomach and going deep into the abdomen section, and it is highly coiled structure. It comprises of three sections, that is anterior part is referred as duodenum, middle part is referred as jejunum, posterior part is referred as ileum. So small intestine comprises of three parts: duodenum, jejunum and ileum. Okay, the light blue section is your duodenum. The dark blue section is jejunum. The green section is ileum. Okay, so you have to repeat these names after me. That small intestine comprises of three important regions. These regions are duodenum, jejunum, and ileum. Okay, the wall of the small intestine is very interesting. It is having finger-like projections, and these finger-like projections are referred as villi. Why these finger-like projection need to be there in small intestine? What is the role of these finger-like projection into the small intestine? As you know, small intestine is meant for the absorption of the digested food. So to maximize the absorption, these finger-like projections are there. As you know, finger-like projections are meant to increase the surface area. If surface area is going to be increased, there will be the maximum absorption of the digested food. And it also helps in mixing of the food with digestive juices which are being coming into the small intestine. So small intestine is meant to the absorption of the digested food with the help of finger like projection. As you can see in the diagram, these finger like projections are referred as villi. Okay, and they are meant to increase the surface area to maximize the absorption of digested food and aid in mixing of the food with digestive juices being secreted into the small intestine. Okay, now we will look into the interior section of the small intestine, and you will find a beautiful finger-like projections, and these projections are referred as villi. These villi are meant to increase the surface area of a small intestine, and ultimately this will lead to maximize the absorption of food, and these villi also aid in mixing of food with digestive juices so that digestion can occur in a proper manner. Okay, this is the section from where you can see these finger-like projection or the villi. Okay, I hope this part is clear to you. Now comes to the function of the small intestine. It is a site where the digestion used to be completed. Whatever kind of food substances constitute, that is carbohydrate, fats or protein being coming along with the food, these need to be digested up to that of the small intestine. As far as I can recall, in 2016 this question has been asked into the MCQ, so you can understand the importance of this part, that it is a it is a part of the alimentary canal. Small intestine is a part of the alimentary canal where the digestion is being completed. Okay. It is also the site of absorption of digested food substances. As we have seen earlier, villi are meant to absorb the food substances. So these villi are being present in small intestine. And to maximize the absorption of the food substances, these villi are there to increase the surface area and absorb the digested food substances. It also transport the remnant of the food, whatever coming from that of the small intestine to the large intestine. Whatever part is being unabsorbed or need to be go for the further processing, they used to go into the small large intestine from that of the small intestine. The undigested food used to move from small intestine to the large intestine. Okay, so we can recapitulate the function of the small intestine. It is a site where the digestion used to be completed. It also helps in absorption of the digested food substances with the help of the villi. Okay. It used to transport the undigested food substances to the large intestine. Okay. Now, the biggest question comes about the length of the small intestine. As you can see over here, two animals are being placed. One is rabbit and other one is fox. As you know, rabbit is herbivore and fox is carnivore. And when we are going to compare the length of the large intestine, it is quite longer in rabbit or in most of the herbivore like cow, buffalo. Okay, and in carnivore it is used to be slightly less longer than that of the herbivore. Why it is so? Why there is a difference in the length of a small intestine in herbivore or carnivore? Okay, so we have to discuss the reason for this length difference in the small intestine. As you know, herbivore used to eat plant or the plant product. They used to survive on the plants, and plant have cell wall. And from ninth standard, you can recall that cell wall compose of cellulose. Okay, so cellulose is the important integral component of the cell wall, and this used to come along with that of the food substances into the herbivore, and cellulose takes a lot of time to get digested with the help of some of the ruminant bacteria, as the case of cow and buffalo, because these are the ruminant animals. So some of the bacteria being present into the small intestine used to secrete some of the enzymes which help in digestion of cellulose. So, for the action of these enzymes, the length of the alimentary canal to be longer one, so that food can stay over there for the longer period. And in case of carnivores, however, the cellulose is not there because they used to feed on animal. They used to eat the animal part. So in their diet, there is absence of cellulose because cell wall is going to be absent into the animal cell, and there will be no cellulose, and the digestion will be the quicker one when we compare the time gap of digestion of cellulose diet or the diet which do not comprise of cellulose. So cellulose takes a longer time to get digested, and in case of animals like cow or buffalo, there are the presence of ruminant bacteria which need to secrete enzymes, and these enzymes are going to work on the cellulose and convert into the simpler form or absorbable form. However, this cellulose component is totally absent in the diet of carnivore. So the length of the small intestine is quite lesser or quite less longer than that of the herbivore. Okay, in carnivore, the length of the small intestine is shorter, and in herbivore, it is quite longer. You have to understand this fact that herbivore feeds on the plant product, and plant product basically comprises of cellulose, and cellulose digestion takes a longer time because some of the enzymes being secreted by the ruminant bacteria, and this takes a lot of time, so the food need to be there for a longer period. That's why the length of the small intestine in herbivore is quite longer when we are going to compare with that of the carnivore. Okay, I hope this part is also clear to you. Now we are going to compare the small intestine in various organisms like carnivore, omnivore, herbivore. In carnivore, you can see the length of the small intestine is quite a lesser or shorter one, and the length of the small intestine in omnivore is quite in the middle range of carnivore and herbivore, and it is longest in case of herbivore. As we have discussed earlier, herbivore used to feed on plant product, and plant comprises of cellulose, which has been present in the cell wall, and cellulose takes extra time to get digested with the help of some of the bacteria being secreted into the small intestine, and this food need to be there for the longer period so that proper action of the enzymes can take place for the digestion of the cellulose. Okay, now comes to the large intestine. Large intestine is about 1.5 to 1.8 meter long. It is quite shorter than that of the small intestine. Then why this is referred as a large intestine? As you can see in the picture, the diameter of the large intestine is more than that of the small intestine. That's why the large intestine is referred as large intestine. However, the length is quite shorter than that of the small intestine. We have to understand this fact: the diameter of the large intestine is quite more than that of the small intestine. That's why it is referred as large intestine. Otherwise, the length of the large intestine is quite shorter than that of the small intestine, and there is no digestion takes place into the large intestine. Only the absorption of water and electrolytes used to take place there, and after absorption the fecal matter used to be formed out, and the large intestine comprises of three sections, that is caecum, colon and rectum. As you can see in the diagram, this is the caecum section, and colon section again comprises of four parts, that is ascending column, transfer, this horizontal section is the transverse column, and the descending part is here, and one sigmoid column is also there. You can see in the diagram part. Okay, it is the transverse section of the colon but in the opposite direction. That's why it is referred as sigmoid colon, and ultimately it turns into the rectum section. Rectum is that part where the fecal matter used to store for some time. So after filling of the rectum, the urge of discharge of the fecal matter happen in our body. Okay. Function of large intestine. Large intestine does not absorb nutrient, as I have told you before, that it doesn't play a vital role in absorption of any sort of nutrient in terms of carbohydrate, fats, or protein, but it used to secrete the mucus, and this mucus help us to discharge fecal matter in a very relaxing way. Otherwise, the hard substance can't be excreted in a easy way. So this mucus is very very important in terms of discharging of fecal matter. It used to absorb the electrolytes which are being dissolved into that of the water. Absorption of water again take place into the large intestine, and semi-solid mass, that is fecal matter, is going to be taken or expelled out from the rectum to the anus and finally discharge it out from the body. Okay. Now comes to the digestive system once again. We have discussed alimentary canal from mouth to the anus. Now we are going to discuss about the associated gland. These glands plays a vital role in digestion process. However, why these are referred as associated glands? Because food do not come in direct contact with these glands. They used to secrete their secretion in some part of the alimentary canal. We will discuss here. So they help in digestion, but they do not play a direct role into that of the digestion. Okay, food is not going to come in direct contact with these glands. That's why they are referred as associated gland or accessory glands. These are salivary glands being present into the mouth, then liver, then pancreas. Okay, three associated glands are there: salivary glands, liver, and pancreas. First associated gland we are going to discuss is the salivary gland. It used to secrete saliva which is slightly acidic in nature. The pH value I have told you before, that is 6.8. Okay. It contains water, mucus salt, salivary amylase enzyme, that is ptyalin. The other name of salivary amylase is ptyalin. Okay. And lysozyme. The role of salivary amylase is to digest the starch content into the food. And lysozyme, what is the role of lysozyme? It is used to digest the some of the bacteria or lyse some of the bacteria which have been coming along with the food substance. Many times we see food and water comes into our mouth whenever we are going to see pizza, burger, or any other delicious food substance. The saliva used to come in our mouth. That represent our hungerness. Okay, so saliva represent our hungerness, and saliva is going to be secreted by salivary glands. Okay. Salivary secretion. Salivary secretion, as I have told you before, it comprises of water, salt, mucus, and enzyme. What kind of enzymes being present into the saliva? That is salivary amylase, ptyalin, and lysozyme. Saliva from salivary gland is transported through the duct into the mouth. As you know, these are the duct gland. These are exocrine gland. Whatever I am telling you extra, please write it down or note it down in some of the notebook. Okay, bio notebook, of course. That is saliva from salivary gland is transported through the duct, and salivary gland are the exocrine glands. Okay, they are the duct gland, not ductless. Okay, these are the duct glands. Or small quantities of saliva are secreted all throughout the time. If I'm talking right now, saliva is being secreted in my mouth. But when I'm going to eat the food, the excess of amount of saliva is going to be secreted. And this excess of amount of saliva helps in digestion of what kind of food substance? Recall, right? That is starch. Okay. Now comes to the function of this saliva. It used to moisten the food. It used to soften the food substance, binds the food particle together to form the bolus kind of thing. And this bolus used to be like going to the esophagus in a ball-like form. We have discussed it earlier. Bolus is a ball-like form of the binded food particle that's moved into the esophagus. It helps to clean the mouth and teeth. As you know, it is a fluid substance used to clean the mouth and the teeth. And the enzyme, that is lysozyme, is going to kill the bacteria which are coming along with that of the food substances. Thus, it acts as an antibacterial agent. Okay, we have done two antibacterial agent today. That is, one is HCl and another one is lysozyme. HCl is being secreted into the stomach, and lysozymes are being present into the saliva. Okay, starch is going to digest it into the maltose. You have to remember this term. Starch is going to be digested into the maltose with the help of salivary amylase. Okay, that's why when we are going to chew the boiled rice, it's used to taste sweet because maltose is sweet in taste. Okay, it allows taste of the food by acting as a solvent. Uh, Saliva used to act as a solvent so that we can taste the food in a proper manner. Whatever the taste of the food, either bitter one or sweeter one, we can taste when the food is going to be mixed with the saliva. Saliva act as a solvent so that we can have the proper taste of the food substance. Just recall it once more. It is a very very important topic from CBC point of view. It moistens the food. Saliva helps to moisten the food or soften the food particle. It used to bind the food particle in the term of bolus. Bolus is a ball-like substance, or the ball of the food which is going from the mouth to the esophagus. It helps to clean the mouth and teeth. As you know, it is a fluidy substance used to clean the mouth and teeth. And it comprises of two important enzymes. One is lysozymes, which used to kill the bacteria, which is being coming along with that of the food substances. So that in this term, it acts as an antibacterial agent. And starch is going to be digested with the help of salivary amylase to the maltose. Or maltose is very very sweet in taste, and it is going to be present into the rice when rice is going to be digested into the mouth with the help of salivary amylase. That's why boiled rice used to taste sweet. Saliva also act as a solvent so that we can have a proper taste of the food substance. Now comes to the liver part. Digestive gland associated with the small intestine. This gland is going to be associated with the small intestine. It is the largest gland. This is going to be asked into the CBSE board examination. This is very very important. It has been asked again in 2014 and 2017. So you have to remember the largest gland being present in our body is liver. It is being present in the upper right section of the abdominal cavity. You can see over here, this is our abdominal cavity on the upper right section of the body concern, not your body. It is the body concern. It is a the right section of the abdominal part. You can see over here, it will be left from your side, but from the body concern, it will be the right section. So in the right section of the body concern, the liver will be present in upper right section of the abdominal cavity. And the weight is 1.5 kg. It's the largest gland in the human body. Now comes to the digestive function of the liver. Liver used to secrete the bile. Bile is yellowish green substance, and it is going to be secreted with the help of some ducts. And this bile is going to help in the emulsification of the fat. Emulsification of fat, what does it means to you? Emulsification refers to breaking of the bigger globlet of the fat into the small droplets. Okay, when the bigger globlet of the fat molecule is going to be break down into the smaller droplet, it is referred as emulsification of the fat. Bile juice also help in creating alkaline medium. You can see the food which is coming from that of the stomach is acidic in nature because of the secretion of HCl in the stomach. But when food is going to come into the small intestine, the alkaline medium is being provided by the bile juice. And this alkaline medium is very very important because various enzymes are going to be activated in small intestine in alkaline medium. Please highlight this word. The bile juice is going to provide alkaline medium so that various digestive enzymes in the small intestine can work upon the food substances and digest the food. Okay, bile juice do not contain any sort of enzyme. This is very very again very important point. As you know, the bile do not have any sort of enzymes. Bile salts help in breaking down oil droplets into the small globules. That is emulsification of the fat. Now you have a clear cut idea of what I mean by emulsification of fat. That refers to breaking of the big oil droplet into the smaller globules or droplets. And you can see over here, the fat in presence of bile is going to be emulsified. Okay, the acidic kind which is being coming from that of the stomach is going to be alkaline in presence of bile, because bile is going to provide alkaline medium to the food. Okay, and this alkaline medium is provided by bile salt. Bile have many components. One component is bile salt. Bile salt is responsible for providing alkaline medium to the food substances. Now you can see the emulsification process over here. The big droplet of globule of the fat is going to be break down into the smaller globules. And what is the reason of breaking of these big globules into the smaller droplet? That is because enzymes can work very easily on small drops rather than of the big drops. Okay, so big droplet is going to be converted into the small globule with the help of bile. And you can see over here small dot kind of structure is being present. These are your bile salts, which protect in binding again the small globules to make the big globule. Okay, so it prevents binding of the smaller globules into that of the bigger fat globule. Okay, you have to understand this fact. This emulsification of fat is very very important from the point of view of digestion of the fat, because enzymes can't work on the big globule. They used to work on the small droplets. As you can see over here, the enzymatic action can be very easy on the small droplets. You can see over here. Now comes to the pancreas. Pancreas used to secrete four important enzymes. These are trypsin, chymotrypsin, pancreatic amylase. This is different from that of the salivary amylase we have done earlier. So you have to write pancreatic amylase. If you write only amylase, it doesn't make any sense. So you have to write the whole word, that is pancreatic amylase. And the last enzyme, that is lipase. As you know, it is a duct gland, so it is exocrine in nature. You can see the action of various enzymes. That trypsin help in digestion of the protein in alkaline medium, because alkaline medium is being provided into the small intestine with the help of bile. Okay, so alkaline medium is being provided by the bile, and proteins are going to be digested into the smaller unit, that is polypeptide. Chymotrypsin is going to be help the protein digestion part, and proteins in the presence of chymotrypsin is going to be digested again into the smaller protein molecule. Pancreatic amylase help in digestion of the starch in alkaline medium to convert starch into the maltose. Maltose is a sweeter sugar. Lipase help in emulsification of the fat in alkaline medium, and you can see that fat is going to be converted into fatty acid plus glycerol. These are the end product of digestion of a lipase. Okay, so all these enzymes you can see over here work in alkaline medium. You have to remember this fact. The alkaline medium is provided by bile, right? Okay, that's all for today. Thank you.